Okay. Well, again, let's start then. Again, this is going to be just a basic introduction to Kubernetes Helm, as well as Kubernetes operators. Real quick question: anyone use Kubernetes for their day-to-day work?
Yes.
Yep. Yeah, there you go. Again, it's quite common nowadays, especially for containerized workloads. Let me start this presentation. Okay. And what is Kubernetes? Kubernetes, or shorthand is K8s, is an open source container orchestration platform for automating deployment, scaling, and management of containerized software. Originally created by Google 2014 and is right now maintained by the Cloud Native Computing Foundation, CNCF. You might know Sam, they handle quite a bit of open source software. Yep. And containerization. Containerization is the packaging of software for the operating system libraries require dependencies to run in a single executable package. Adoption became popular with the release of Docker. Now, with Red Hat, Podman is picking up space. Podman, the basic focus of Docker. Again, with Red Hat's focus more on security, though recently there has been a major CVE with Red Hat OpenShift, which is their flavor of Kubernetes. You should look into that if you haven't heard of that. But yeah. Basically, with containerization, you're sharing the hypervisor or operating system kernel, which with the host OS, which is much more efficient instead of having to run multiple kernels using hypervisors or multiple entire OS installations with hypervisors. And Helm helps you manage Kubernetes applications. Helm charts help you define, install, and upgrade even the most complex Kubernetes application. The charts are easy to create, version, share, publish. Again, this is again taken from Helm's website. Okay. Again, known as the best way to share software using Kubernetes. Let me punch through my screen. Yeah, right here. Now let's go back to. You can think of Helm as a templatization engine, which basically at core is. Also, Kubernetes, again, is the foundation for the structure of the infrastructure. Helm is what you use to configure, basically, yeah. Let me fix that. Now, Helm v2, client server model, big upgrade from the first initial version of Helm, which required Tiller on the back end, which because there's security risk. Helm is, again, a client that runs just on your local system, basically a templatization manager, and a client that can pull from, again, chart repositories, which I'll demonstrate later as well. Tiller, with again regarding to Helm v1, a server that runs inside your Kubernetes cluster is deprecated as it was a security risk because I had to run it as root. Used to manage the installation of charts, and as I mentioned, considers a security risk as requires root permissions. And now Helm v3 client model. Of course, Tumblr has been removed, and all templating is now done on the client side. What Helm provides a package manager for Kubernetes with templating. Offers flow control, version control, dependency management. Of course, written in Golang, and utilizes the Go templating engine. You can find in the link. I'll share this link's presentations afterwards. If you ever use Golang, good language, there's tour of Go. Get you up to speed. It's very similar to Python in many regards. However, offers quite a bit of the performance benefits of a compile-based language of an interpreted one. Back to presentation. Now, flow control basically enables specifying variables for specific environments, local development, production, for example. So you can have with Helm, you could have local variables.yaml for your local, for your dev environment, dev variables.yaml for dev, shared dev environment, and then for prod variables.yaml, and of course testing variables.yaml, QA, whatever you want to name it, and control structures. You have support for if-else, if you have something specified, and take that as true and use conditional blocks with specifying a scope, like an if, and range, loop control. Here's a templating guide. Pull that up. Yeah, as you can see, you have your if-else. Not sure if you can see the mouse on the screen. With range. And yeah. Go back to the presentation. No, Eric. Again, like I said, I'll have this recorded and I'll share it afterwards. We just went over the basics of flow control. Now pipelining, of course, you have your if-else. So if values prod, debug false, obviously, hostexample.com, or 443. If values stage or dev, debug can be enabled still. You can specify host as dev.example.com. And of course, your default case. Go back, sorry. Debug true, basically your local work. And another thing, note, dash and space does remove white space. If you do it from the right here, let me open brackets, moves white space from the left, or then close brackets moves white space from the right. Pipelining. Example. Here, in case you have prod, of course, debug false. And of course, you have to dot specifies current scope, current working directory. And flow control range, basically your loops. For if you have a list of users, go through that list of users, such as users Alice, Bob, Charlie. Just one iteration for Alice. Next iteration will be for Bob. Third iteration will be Charlie. And of course, version control. There are quite a bit of options for version control using Helm. One is originally with Chart Museum. Open source repository for storing Helm charts, supports many third-party object storage platforms for storage. This also supports storage on local file system. However, that is not the only option anymore. Now there is, of course, GitLab. And 14.1 introduce support for this. And go through that. Of course, this is in all. Not sure what kind of Git options you use in your environment. But if GitLab, pretty much I would like to consider it as a combination of your JFrog Artifactory, as well as your Git or instance. So it has both the package management as well as source control. And Helm is one of the supported package management in GitLab. Back to the presentation. If I'm going too fast, let me know. Again, even in the software as a service option, it's supported, so you can try it for free. GitLab.com. Now, a new one, GitHub. Using the chart releaser, a package by Helm, as well as GitHub Actions. It's a great introduction to GitHub CI/CD workflows using GitHub Actions, actually. You can, again, use GitHub, and this is using GitHub Pages as the repository. An example. In chart releaser, let me pull that page up. Again, helps turn GitHub repositories into simple chart repositories. Using GitHub Pages, there is a locally installable CLI utility. However, you really don't need it, because with using this, basically you're going to be, as I mentioned, and I'll also probably do a demo as well. As soon as you merge, do a PR request and merge to main, the GitHub action pipeline goes through and publishes the chart to GitHub Pages. Again, as mentioned here, you can pull this basic YAML configuration up. As you can see here, basic YAML CI/CD configuration. This commit. Whenever, again, there's a push on to merge request, merge to main. As you can see here. As part of my demo. Go back to my presentation. And of course, dependency management you can have. The Helm also supports for parent child charts or dependency charts. For example, using the Prometheus stack. This one actually is what I'm actually going to demo later today as well. Let me. As you can see here, you have dependencies. CRD is enabled. Cube state matrix. Prometheus node exporter. Grafana is a big noticeable one here. It's referencing the Grafana chart as a dependency. Is this visible for you guys?
Yes.
Should I zoom in? There we go. That's better. No, because I just noticed you joined. Welcome.
Yeah, thank you, thank you. Yeah, it's visible now. Yeah, it's clear.
Okay. Any questions so far? I'll go back to the presentation. And of course, creating a simple chart. As part of the presentation, you can do a Helm create, my chart. Actually, you know what? Let's try this. Let me go to my machine. Also, I'm looking at multiple windows. Prometheus demo. going to do a quick demo with this, and then we're going to also do a chart release around this machine too. So you go to a clear directory. And let me fix this. Something else. Motion over Chrome tab. I do have. See if I can zoom this in. It's going pretty bad. So what we're going to do, as I showed you from previous, I can actually just over. I cannot. Going to do a Helm create. Let's first actually. Let's go to my Helm chart repo. We have a new chart, my chart created. And of course, you can see my chart is there. I'm going to move my chart to charts. Actually, no, let's go back to charts. So create it from here. Let me clean up this error I made here. Right now under charts. And of course, still using the example charts. It's the entire structure there. From the repository. Now I have that pushed. However, this is still under the my charts branch. What we need to do now, let's go to Git. A minute. It's under Helm charts. Let me share it. Go back here. The branch. We're going to look for is example charts. It's one commit ahead now. Going to make a pull request. So we're going to be merging example charts into main with a new my chart. See how the code this could be committed. A new pull request. 1 minute. Able to merge. Okay, why are we not allowing to? Can be ically merged. Okay. A minute. And of course, log me out of the GitHub. No wonder why. 1 minute. And this will be again just for my chart. Now you'll see an action under here. Happy completed job. Basic introduction to CI/CD here. And if you go into the GitHub pages, you'll see index.yaml. And from here, we'll find my chart. I can do. And now let's go back to terminal window. First of all, any questions? Anyone following along? Pull up the.
Yeah, we are good. Yes.
Okay, yeah. You can see here, you can see a list of the installed Helm repo install. Will give you these, such as the example charts.haupt.com, which is using the GitHub pages. Update, and update Haupt chart. Yeah. Let's go back to the presentation. Okay. You can see here that you have the simple chart. You have template tree where the Helm reads the YAML. Chart YAML contains metadata and values, contains the default values that are set. Go more detail with this later. Also show you some examples with the Prometheus stack regarding this later presentation. A minute. Of course, Chart Museum can be run by Docker, simple Docker run. And Docker is going to be the building block prerequisite to Kubernetes. If you have to start with Docker, get familiar with the basics of containerization, build a simple, like I said, application in Docker container, such as a simple Python fast API service. Then from Docker, work your way up to Docker Compose, then Kubernetes, then finally up to Helm. Now let's go to Kubernetes operators. Operators are software extensions to Kubernetes that make use of custom resources to manage applications and their components. Follow Kubernetes principles, notably a controller loop. For, right here, let me pull this up. Operator pattern documentation. And the zoom in is kind of small, what I'm seeing. If I'm zooming in on the right screen. Fix the machine I did not want to zoom in on. Again, use the operating pattern. Big example with these is automation for specialized tasks, such as, most simply, managing a database in your Kubernetes cluster, such as you want to update the version of your Helm chart. You can use your operator to automate the process of taking a snapshot of the persistent volume containing database data. So you have a backup of that as a fallback. Because with containers, obviously, there's no persistence. In order to maintain persistence, you have to use persistent volumes, which are basically just file share amounts that the container can access. Of course, things you can do with the operator: deploy application on demand. And as mentioned, application code related to especially database change. With databases is where they're really handy. As mentioned with that sample DB is documented. Basic extensions of Kubernetes and also the Prometheus stack utilizes its own operator for Prometheus custom resource definitions. They're specific to Prometheus stack. And again, going back to database, if you delete it, the operator takes a snapshot automatically for you to make sure stable set volumes are before removing the volumes. You can also handle regular database backups. Quite flexible for what you can do. Anyone use operators, custom operators?
Yeah, I have heard that. Yeah.
Yeah.
Yes. Yes.
Just for database work or anything more specific?
Just the database work. That's it.
Yeah, as mentioned here, yeah, that's where they really shine. Database, keeping the database backed up before you do a delete or update, or just periodic scheduled database backups.
Yes, only just database backups.
Yeah.
But it's complex, right? By using the open Kubernetes one, like you can use EKS as well, right?
Yeah. Back to our presentation. Again, as mentioned, the extent of functionality by defining custom resource controllers and operates a Kubernetes controller that's specifically designed to manage and operate a particular custom resource. Go into the Prometheus ones in a demo, and they enable the automation of tasks without complex scripting, such as, again, maintaining database backups, as we talked about. And example, taking snapshot volumes used by a database during version updates, as mentioned. Controllers. They're a component of the Kubernetes system responsible for managing and maintaining desired states of resources in a cluster. And of course, the live walkthrough, we're going to be using Terraform or /OpenTofu now. Of course, Helm on manage Kubernetes using the Prometheus stack, as well as the Bitnami Ingress Nginx controller, using an issue with the DigitalOcean, specifically with the official Nginx Ingress controller as it's kind of breaks flow of infrastructure as code. If you do a Helm apply or install the official Nginx controller, DigitalOcean spins up a load balancer for you, right? Like I said, breaking flow. But in this example, let's go with put link, the Prometheus stack. First of all, anyone use Prometheus for work? Observability?
Actually, I haven't used in the work, but I have hands-on experience on Prometheus and Grafana as well.
Yeah, same. It's great for, again, with the most commonly used, especially in the open telemetry area for keeping observability, keep track of system metrics.
Yes.
And what we're going to be using here is the open source Prometheus community Helm chart. You can, of course, see by the chart.yaml the metadata with the dependencies. Prometheus Windows or Grafana is a subchart. Again. And let's go to the values.yaml. We're passing in, these are, with how we're doing this, these are just the simple default values, such as, let's go to Prometheus. Of course, create default rules. That's enabled by true. Prometheus enable monitor true. There you go. You have the custom resource definition enabled by true defaults. Alert manager will be installed as default true. Same as Grafana. Not using much on persistence. This is very basic tutorial demonstration. Source monitors. And you have the node exporter. Node exporter is basically the metrics for the Kubernetes cluster itself. Let me zoom this a bit. Go back to the presentation for a minute. Of course, you're going to need a ingress. Ingress is basically what allows to reach additional services. Okay. Now let's go to my live demo. Let me move this window over. Meantime, any questions? Trying to get some involvement here. Let me bring this over as well. No. And maybe zoom this in a bit. So now, the Helm charts. Let's go to Prometheus demo. And let's go to community. Going to be using here is Terraform to apply this. Terraform can take a few minutes. That's why I'm going to run it first. Or you can use Terraform or Tofu, which is Terraform. I mean, OpenTofu is Tofu is a fork of Terraform. So you can just due to license issues that occurred when Terraform changed or HashiCorp changed the licensing. So it'll be Tofu init instead, since that's what's installed on this machine. Now, it'll be Tofu plan. A minute. Get the recommend. Go here. Oh, that's there. Go ahead. A minute. Of course, secret to you first, we'll have the DigitalOcean show, but what you were going to do is Tofu plan. First file demo TF is what has the there he is. Now the plan. Here is the what's going to be built. 10 resources. Start from the top. It's actually going to be live. You can once this completes, you can go to prom.dsort.net and actually see live Prometheus. But we're going to do a DigitalOcean Kubernetes cluster. Start with just 2 nodes. Scale up to 3, but we're going to start with 2. Load balancer for the ingress is required. Of course, A records one for alert manager would be alert.dsort.net. Check you're saying that. Yes, you are. Yeah, then Grafana, graph.dsort.net, node.dsort.net, prom.dsort.net. Then, of course, you have the Helm release. This is where we're actually installing the Kubernetes stack. And, of course, the Nginx Nginx chart. And to override it, overrides variables as a set. These will be your quote. If you're using Helm install through the CLI locally, you'll just be passing them these as your variables. YAML. However, in Terraform, you send them as set variables. Very similar process. What I had to do here since we're using the Bitnami chart, which is officially, Bitnami's been trying to deprecate their open source work, which was really good back then, but now this just happened a couple months ago, end of August. They did move all their repositories from Bitnami to Bitnami Legacy without updating their charts. So in order to get this ingress chart to work, I had to pass in the updated image repository values as overrides for the default, which I showed you with values.yaml on the, well, yeah. In here, of course, you have a default ingress. We're specifying service name, the service port, the host, such in this case is the Prometheus to matching to prom.dsort.net. Same for alert manager. Internal service name, kube Prometheus stack alert manager. Internally import 9093. This will be under externally reachable now, then as alert.dsort.net. Similar for Grafana, then finally similar for node exporter. Now we're going to do an apply. Wondering how this is actually working with DigitalOcean. That what's in secret.tfrs, which I'm not going to show you, is a API token for DigitalOcean's backend API. DigitalOcean service is very similar to AWS for infrastructure service. So we're going to do an apply. How this is going, I'm going to show you. Zoom. Come on. Actual. Under TF, you'll have all the Terraform configurations, such as go under Vim main. Again, you have the providers listed in main, DigitalOcean, Kubernetes, and Helm. This is again after the cluster resources created. It's how the Kubernetes provider and as well as the Helm provider, which is a subset of Kubernetes, interact with the cluster using values from the kubectl, kubeconfig. Let me zoom in on a bit. And of course, I'm going to post this Git repo afterwards. I can't zoom in. Now, demo, simple. So assigning a cluster name, the cluster version. This is from the DigitalOcean Kubernetes slug. We're using 1.32.5, DO.5. Region, New York City 3. Host domain, dsort.net. Specifying min nodes of 2. And the subdomains, prom, alert, grafana, and node. So it'll be prom.dsort.net, alert.dsort.net, graph.dsort.net, node.dsort.net. Now I'll show you the cluster. Or I can also show variables is safe to show. Variables, again, the variables that were referenced from the demo.tfrs. Of course, can't show the token as it's protected, sensitive, but the cluster name, cluster version, region, host domain, host names, the list of the prom, alert, graph, node, min nodes, default 1, but we're using 2. Of course, a max of 3. And full node size, 2 vCPU, 4 gig RAM. Now let's go to the cluster. Of course, here you see the DigitalOcean Kubernetes cluster resource name, default cluster, taking the variables, the cluster name, region, cluster version. I'll scale true, can go up to 3, but we're using the min of 2, max of 3. Now let's go to that. We have the cluster, we get to the load balancer. Simple load balancer configuration, burning 80. So required for the ingress to work. This connects to both of our two Kubernetes nodes. Yeah. Let's go now finally. Ingress.tf. Well, let's leave that for last. Let's go to DNS. Ingress is where it's the real interesting one. Of course, here the host domain, this will be dsort.net, and for each of the 4 subdomains, prom, dsort.net, graph.dsort.net, alert.dsort.net, and node.dsort.net. Which are all going to be automatically configured. Now best ingress. Here we go. Let's go to the top. Of course, you see a Helm release. Kubernetes. This is where we're installing the entire Kubernetes stack Helm chart. See under default namespace, the repository specified there. Chart Kubernetes stack, and for the values.yaml or equivalent for how Terraform handles it, Terraform/OpenTofu as set parameters. Key value, so we have a name of grafana.admin user. It's not, again, of course, not secured as proof of concept, but I'm doing, instead of using the default of admin for Grafana user, we're going to be using Grafana user as override. And some concept for password. So if Prometheus operates the default, we're just going to use Prometheus op. Now, yeah, of course, it depends on, cluster has to be ready first. So let's wait for that. Now we have the Nginx ingress chart. And of course, the duct tape fix I had to do with the Bitnami Nginx ingress, since they did change their repository from Bitnami to Bitnami legacy as they tried to deprecate their work. I had to do overrides for each of those. So for both the ingress controller and the standard Nginx ingress image itself. Of course, this also has to wait for the ingress chart, has to wait for the load balancer to be ready. That's what it depends on. Now the default ingress required for Kubernetes, and see here, one prom.dsort.net will be reachable. I mean, this will be for Prometheus, reachable under prom.dsort.net. Maps to the Kubernetes stack Prometheus. Point. Similar alert manager, alert.dsort.net, Kubernetes stack alert manager, Grafana, graph.dsort.net, Kubernetes stack Grafana internal service, node exporter, node.dsort.net, Kubernetes stack node exporter default service. And yes, I just saw from your local, what you send commands to DigitalOcean. Create 10 what? What do you mean, Jeff? Yep, again, if you had drop early. What's the terminology? I'm trying to confuse what your question is again, Jeff. Contain. Oh, you mean the nodes? That's again, creating it 2 nodes. Not really specifying 10 containers anywhere specifically. Sure where you saw that. I'm not again real sure. I'm a little confused here. What do you mean, Jeff, here? So 2 nodes. Now the process should be completed. Yes, 10 resources. That's what you meant. You said 10 containers, so create 10 resources. Those will be the DNS names, ingress, load balancer. These are the Terraform resources. Okay. Oh, sorry, again, a little confused what you meant by containers, but yeah, we got it. Now that this is ready, let's go to any other questions, anyone? Can't do much to show you with this, but wish I could show you the DigitalOcean terminal, console, but there's other sensitive information on it, especially from my main website. So what I'm going to do right now is, though, from the DigitalOcean console, you can, as you can see here, all 10 resources are ready. After this point, you can go to the console, click the cluster name. I can show you the cluster name, which is already created. It's the Prometheus demo cluster. Show you this page. Can do a download config. Once that config is downloaded, let me envy it over. Basically, I'm using Windows subsystem for Linux, so what I'm going to be doing now is prom demo. So after you download it, you just need to put it into your kube config repo, which is home./cube/config. Do a simple MV. I want to show that as, again, risk of showing sensitive information. Now that we have that, we go back to the terminal. I'll zoom in again. can see here, we already now have a Kubernetes cluster. Get nodes, 2 nodes, prom demo, and it can do get pods. This is all the service pods. Then deployments, basically the Grafana, Cube State Matrix, Prometheus operator, Ingress controller. And we also have services. See here, we have one for Alert Manager, Grafana, the operator itself, Prometheus, and the node exporter. These are the services. The ingress pointing to the host of prom.dcernet, alert to dcernet. So on. External IP address. Now, let's actually go interesting one. Actually show you demo. So the Prometheus time series. Right here, let me move this window over for my sake. I'm much here. Manager failed reload. Some query here. These are the default learning configs that were shown. Oh, we have something firing here too. These are again just default Prometheus rules. It's vector 1. And this is again to show a simple test one to make sure the pipeline is functional. Yeah, zoom in. If you're curious, you can type in prom.dsort.net on your machine now. This is again running. It's nothing about Terraform. You can get an entire set of services up and running very quickly, doing infrastructure as code. Simple proof of concept out there, and you can also tear them down just as quickly. So we have the alerts. Things seems to be going good. Again, these are just your standard cube state metrics for the Kubernetes cluster itself. Now we can also show you that manager. Any questions? Now here is Alert Manager. We can decently good on time. I know I have to go fast because I'm presenting quite a bit. Silence status, finish disabled, not much real. Now we have the node exporter. So you know how Prometheus works. Everything is basically a web service with metric data. So here the node exporter, node user.net, and here we can see the simple HTTP text report with all the system metrics for the Kubernetes cluster. Now finally, let's go to Grafana. I really don't have any dashboards really set up. Here you can see we're going to be using admin. Grafana user and Haupt login. Actually, 1 minute. No. Shop, yeah. Grafana user. Referencing is what I have saved in the ingress.tf, which is Grafana user, yeah. So Grafana user. Okay, so I cannot type today. There we go. Now we're logged in. Yeah, like I said, there's really not much of a dashboard is like the default. Kubernetes server, kube proxy, Prometheus overview. Grafana is basically your dashboarding utilities for the Prometheus stack. You want to use this for work by chance? Good question. Yep. Not much on learning, but see the data received, transmitted, and with utilization. CPU usage. Just 2 node cluster and memory. Not really much. We're using a very default Prometheus deployment. Yeah, like I said, anyone have any questions? Anything they want me to explain further or show it?
No, this is a lot.
Yeah, I know it's a marathon to get this in 1 hour. Yeah. But yeah, by default, as again that mentioned, releaser, go back to the Prometheus stack. Normally, instead of using, like I said, let's go back to terminal. These will be again specified in your or ideally inventory, or environment values.yaml. But ours is Terraform that does, or Alt/Open does handle variables for Helm a little differently, set parameters. Yeah, so let's go, just let me show you an old example I've done. Prometheus demo from about a year ago. Let me share that. This is the I did from about a year ago when I originally present this, but you could see under values.yaml, again, this basically where you just use your standard YAML nested it with indentation level instead of compared to the, go back to that one. Period level as handled by Terraform or /OpenTofu. But again, very similar concept. You have to chart the variables, just set and configured just very slightly differently for using the Helm command line or directly through Terraform. That's a nice thing with Terraform is it's very flexible and can handle Helm, Kubernetes manifests, also Ansible, quite a bit. Anyone use Terraform extensively? Questions?
How important is it to switch to tofu, do you think?
Depends on what your company is willing to pay for, really. If they're willing to pay for the enterprise license of Terraform, good for them.
Yeah, I mean, I don't know how big our Terraform use is. I think we're still well within like a community license, unless they're going to get rid of that entirely.
I'm not sure what's really happening with the licensing. But again, that's the reason why Tofu kind of came along as something is happening with the licensing. Yeah. Tofu is again just a fork of Terraform before the license change took effect. So if you're, again, like I said, wanting to get this into Terraform Enterprise, feel safe to continue using Terraform. As I showed you here, okay, it's all very easy to take it down. Basically, instead of plyf, wrong window. Yeah, so there's the right window. Okay. Sure I'm showing the right thing. So tofu apply or Terraform apply. Delete. Sorry, destroy. And sure. You can see on red what all the resources are going to be deleted. Of course, the deprecation for the Bitnami. See that here. And they were at least kind enough to put this message in, even though without updating their chart values. Yep. Yeah. That's all I have for presentation wise. If anyone has any follow-up questions or want to network.
Actually, what's going on with Bitnami? Because I didn't know about this whole legacy thing.
Yeah, they're basically doing something similar to what Terraform did, changing their licensing model to more enterprise. This time they're getting rid of a lot of the free container images and charts. This was again announced very end of August.
Great.
Yeah.
Yeah, well, it's like with SonarQube. SonarQube Community Edition's great if you've got like 5 developers all using Java or JavaScript. As soon as you get more fancier than that, you need to spend money, and that seems like all the tools are going that way.
That's what, yeah, including Bitnami now. They're no longer maintaining they moved all their container images to Bitnami Legacy, and they're no longer maintaining them as of August, at the end of August. Well, they're still maintaining them if you get a subscription. Yeah.